You know, a tree can simply explains a lot of engineering, yeah, phenomenon or engineering knowledge. You see, a tree comes from one root and go to a lot of branches, and eventually it has a lot of leaves, right? In computer science, that is what we call as graph database. Or there's one more, I think history or something like that. I forgot actually. But what it is actually, for example, this is all of your data. You see, leaves there are like a lot of them. You have a lot of data because you're so and what is it called? Like when you really like yourself. Forgot actually. Hmm. Let me think. Give me time. Because you're narcissistic. Narcissistic. That's why you have a lot of data. But then me, I'm big, I'm thick, you know. But I'm just one, and I want to search something from all of your data. How I can do this? I go up, and then see in the first branch, I see, oh, maybe I will go to the left. That's probably where your data is. All right, I go to the left, and then I will go and go. So let's say there are around 1,000 of branches or 1,000 leaves here in this tree. Instead of looking all of 1,000 data, instead I can just look at 100, and that's how we do the search. We go up, we go just to one branch, we go to a smaller branch, a thinner branch, and thinner branch, and eventually we find the data. And that's how we normally do the most efficient search on computer science. And that's why you just have to look outside, go to the forest, and then see about the nature. You don't even have to read it from a book, you know. Well, you can actually. Eventually, I actually read it from a book, but you gotta make connections also to the nature. Then you actually understand. Actually, I think I can. Let's see if I can find another engineering stuff with it. So, well, the computer science is a perfect example because we use it also in embeddings. We use it in just normal data. Let's go a little bit here, cameraman, because there's a bicycle. Oh, look, bicycles also. You see, there's momentum. And then, you know, sometimes I think about bicycle, and then is there a better form than a bicycle? That's the question to you. Think about it. Let it sink in. But actually, it's very difficult to find one. I think that bicycle is actually one of the most efficient form because of the wheel. And then when you have just a wheel, you see, it becomes you have the lowest amount of energy to move forward, right? And then you just push forward. Another important thing from a bicycle is actually the gear. Okay, so you also use it in robotics, but when you see there's a gear, you can have gear ratio. Let's say 1 to 5. It means one cycle. Or sorry, let's say 1 to 5 for amount of torque. So you can cycle 5 rotation, and it will just circle 1. But in fact, it is more powerful. So let's say you're actually traveling very difficult, incline, flat, flat road, and you're like biking, and it becomes very difficult for you to go upwards, right? Instead of go down and then walk like a loser, instead you can just go this 1 to 5. You make the ratio, you make the gear change, and you circle, let's say 2 times, I think, and then it was just circle 1 time. However, you can actually move upwards. You become stronger, right? So what I'm trying to say is like with this gear, which is really awesome invention back in the past, I think in 19th century or some sort, I don't know, that you can actually increase your strength. And by that reason, all of the things in robotics right now, if you're creating a motor, you'll have this kind of gear. And that gear creates these weak links of motor that is just powered by your normal voltage, your normal battery, can actually increase the strength. So that's what we learned about the bicycle that probably right now around 1 kilometers away already. Anyway, back to the tree. It was a little bit diverged. I think there's nothing more we can learn from this tree from the sense of engineering. I mean, yeah, that's about it that I can think of. On the other hand, if we just flip it, that becomes neural network. Because neural network is basically converting a lot of leaves. Because for example, now my eyes is like an image, an image is like the resolutions, right? I'm sure you're familiar with HD, full HD, 4K. 4K is like 4,000, it's like 4,000, I think, just the width or something. If you multiply and you calculate the amount of pixel it has, it's around 20 millions. I might bullshitting actually. I don't know, but millions, like, it's a lot. What the heck? Actually, I don't think I'm bullshitting. It's really like millions. And then, how can you process a data that is like millions? It's just too much. But what you can do is that you make embedding. That means you reduce the amount of these 20 million pixels down to just one. So it's just like this tree. This is basically what's happening for AI as well. So you see there's like a lot of leaves there, and then eventually it goes down and becomes the root. The root itself is basically the embedding that you can use. That's the actual core information, right? And just like a core information, if that core information is cut, then it breaks everything. So I guess that's what we come to conclusions in this forest and this nature. Yeah, I think that's it.